Suppose you have an event that can occur in any instant of time or linear space, for example, lightning strikes or defects on a wire. If the occurrences of the event are independent of each other, we can use the Poisson distribution to find the probability that the event occurs x equals k times in a given span of time or linear space. But what if we wanted to find the time or space until the first occurrence? Now, we could just say, here's the solution, but remember, a problem exists whether or not you know how to solve it. So let's try to figure out how we might solve this problem even if we didn't know how to solve it. And a useful strategy, concrete doesn't hurt. So, for example, suppose lightning strikes a building on average once a week. What's the probability that the first lightning strike will occur 3 days from now? Now, remember, math is easy, English is hard. Since time is continuous and a lightning strike could occur at any instant of time, there's a little bit of ambiguity we need to address. For example, suppose it's 2:35 p.m. on Monday. 3 days from now would be Thursday. But would a lightning strike at 2:34 p.m. be considered 3 days from now? Or should we have to wait until 2:35 p.m. on Thursday? Since this is an ambiguity that's part of the English language, we have to decide how to handle it, and we'll choose to interpret 3 days from now as having to wait for 3 full days before the event occurs. So again, another useful strategy for problem solving. It pays to be discrete. So even though time is continuous, let's suppose for now that our unit of time is the day. Also, since we're dealing with probability, it helps to assume that the lightning strikes are independent events. And because we're looking at the first lightning strike, we'll also assume that lightning can only strike once per day. Then under these assumptions, the probability of a lightning strike on any given day is 1/7. So the probability of the first lightning strike is 3 days from now means there are no lightning strikes for the first 3 days, and there is a lightning strike on the third day. This is a geometric probability, and so we have. However, we could measure time in smaller units. Suppose we measure time in hours. We'll continue to assume that lightning strikes are independent and that lightning can only strike once per hour. So the probability of lightning strike in any given hour is going to be, if the first lightning strike is 3 days from now, this means there are 3 times 24, 72 hours with no lightning strikes. And there's a lightning strike at the 73rd hour, so this probability will be 72 hours with no lightning strikes, and then a lightning strike. Or is it? Well, remember, consistency counts. When we calculated the probability of a lightning strike on the third day, we got, and we'll go ahead and compute that value. If we compute this new value, we get, now we should expect some difference from using a finer timescale, but this is a very big difference, so we should be concerned that we're missing something. So let's think about this. The first probability was for a lightning strike on the third day. The second probability was for a lightning strike on the 73rd hour. But if the lightning strike occurred on the 74th hour, it would still be on the third day. And likewise, if it occurred on the 75th, 76th, and so on. And finally, if lightning struck on the 96th hour, we'd consider that a strike on the 4th day. So we really want the probability of a lightning strike on any of the hours from 72 to 95, which we'll have to get by summing a series. So those probabilities will have t hours with no lightning strike and then a lightning strike on the t plus first hour. And so we can remove that factor of 1/168th. We'll reindex our series so we can start our index at 0, and then we get a nice geometric series where we have a formula that tells us what that sum is, and so we find. And again, if we compare our initial computation with our new computation, again, using a finer timescale should give us a different result, but here the results are pretty close, and so it looks like a refinement as opposed to a totally new answer. The actual computation of the probability when we use a smaller time unit is not any more difficult. For example, suppose we measure time in minutes. Assuming independence and all the other thing, the probability that the first lightning strike is on the third day from now will be the probability that it occurs somewhere between minute 43:20 and 57:59, and that is. But if we measure time in seconds, well, that's someplace between second 259,200 and 345,599, and that will be. And so, well, the computations are not really any more difficult. They are a lot uglier. So let's look at a slightly different problem.